Let us handle one more problem on area between two curves. Find the area of the circle 4x squared plus 4y squared is equal to 9, which is interior to the parabola x squared is equal to 4y. Before we proceed further, just as we did for the other problems, we need to sketch the graph, understand the region and find the point of intersection to proceed with the calculation. So, we have a circle, yes, we are drawing here with the equation 4x squared plus 4y squared is equal to 9 and a parabola with the equation x squared is equal to 4y. Now, let us consider the equation of the circle 4x squared plus 4y squared is equal to 9 and understand what is the radius. That will give us the point at which the circle is intersecting the x-axis. So, 4x squared plus 4y squared is equal to 9 can be written as x squared plus y squared is equal to 9 by 4. Or that can be rewritten as 3 by 2 the whole square. Therefore, r is equal to 3 by 2 and we drop the perpendicular from the point of intersection to meet the x-axis at M. And B and D are the point of intersection of both the curves. Therefore, the shaded region refers the common area to both the circle and the parabola. Thus, our required area is equal to OBCDO. It's time to find the point of intersection now. How do we take it forward? I substitute x squared is equal to 4y in the equation of the circle. So, it is 4 into 4y plus 4y squared is equal to 9 or 4y squared plus 18y minus 2y minus 9 is equal to 0. Now, on factorization, I arrive at 2y plus 9 into 2y minus 1 is equal to 0, leaving out the values of y to be minus 9 by 2 and 1 by 2. Let us check if minus 9 by 2 satisfies our equations or whether it is possible to have such a value. So, if I consider y is equal to minus 9 by 2, x squared becomes minus 18. Square root of a negative quantity is not possible. Therefore, we need to consider it as y is equal to half. We get the value of y to be equal to 1 by 2. Therefore, x squared is equal to 4 times y. So, we arrive at x squared is equal to 4 into 1 by 2, which is equal to 2. That gives us the value of x to be equal to plus or minus root 2. Therefore, the points of intersection are root 2 comma 1 by 2 and minus root 2 comma 1 by 2. Now, we need to mark these in the diagram and try to find the shaded region, its boundaries and then proceed. So, here is the circle and the parabola that are drawn once again for convenience in this page. So, the equations of the parabola and the circle are marked. X squared is equal to 4y and x squared plus y squared is equal to 9 by 4. Now, the points are a of 3 by 2 comma 0. Now, we drop the perpendicular from B to meet at M on the x-axis. Now, what are the points of B and D? That is what we calculated now. B of root 2 comma 1 by 2 and D of minus root 2 comma 1 by 2. Now, we need to find the area of the shaded region. So, area of OBCDO is equal to twice the area in the first quadrant. Now how to find the area in the first quadrant? We split it into two. So area of OBCO is equal to area with respect to the circle minus the area with respect to the parabola. So it is area with respect to the circle minus area with respect to the parabola. Continuing on the same problem, area of OBCO is equal to area of OMBCO minus area of OMBO. So that is equal to integral 0 to root 2 of root of 9 by 4 minus x squared into dx minus 1 by 4 times integral 0 to 2 of x squared dx. So that is, now it's time to apply the root of a squared minus x squared formula. So I get x by 2 into root of 9 by 4 minus x squared plus 9 by 4 by 2 into sine inverse of 2x by 3 within the limits 0 to root 2 minus 1 by 4 times x cubed by 3 within the limit 0 to root 2. So it's time to apply the value. So root 2 by 2 into 9 by 4 minus root 2 the whole square plus 9 by 8 into sine inverse of 2 root 2 by 3 minus 1 by 4 times 2 root 2 by 3. Now let's simplify it. So it is 1 by root 2 times root of 9 minus 8 by 4 plus 9 by 8 into sine inverse of 2 root 2 by 3. This we simplify it, so it is 2 root 2 by 12. So 1 by root 2 into 1 by 2 plus 9 by 8 into sine inverse of 2 root 2 by 3 minus 1 by 3 root 12. So now club the first and the last two terms. So we get 3 minus 2 by 6 root 2 and the next term carried over as it is. So that is equal to 1 by 6 root 2 plus the next term. Now conveniently we will have to write it. So it is root 2 by 12 plus 9 by 8 into sine inverse of 2 root 2 by 3. Take out 1 by 2 as a common factor. So I arrive at 1 by 2 times root 2 by 6 plus 9 by 4 times sine inverse of 2 root 2 by 3. Now this is not the final answer. We will have to substitute in the step that we have come from. So it is total area of OBCDO is equal to twice this area. So substituting, we arrive at what is within the bracket. So it is equal to root 2 by 6 plus 9 by 4 sine inverse of 2 root 2 by 3 square units. So that concludes the answer. Now in these kind of problems only the arithmetics that matters, so I have taken the time to explain it to you.